All right, what's on the bench today? We have a couple circuits here. If we take a look at the circuit, I think everybody has seen this before. Maybe not, but I think everybody's seen this before. You use a quad comparator, and you have a string of resistors here. So you have a resistor divider. So that sets up, 1, 2, 3, 4, 5. So it's 1/5, 2/5, 3/5, 4/5, 5/5. And those are the voltages, right, of whatever you have coming in here. And then your input comes in, and as you increase the voltage, the comparators will start to turn on. This one will turn on, then as the voltage goes up, then finally this one will trip, and that one will turn on. And then as the voltage goes up, the input here, finally this one will trip. And you get a bar graph, right? And so this is very, very, very common in analog circuits, VU meters, and things like that. You'll see this bar graph. This one here caught my eye though, because I haven't seen anyone use it that I'm aware of, and it came out of Hewlett-Packard actually in their optoelectronics literature from the 1980s. And it happens to be the time that I was there. But yeah, they suggest this particular circuit. And it's exactly the same circuit from the LEDs over. This circuit and this circuit are the same. It's just the way you put in the LEDs that's different. And so the way this one works is the same thing. One will fire, then the other one will fire. But if you think about it, if this one fires and it goes high, then you'll have a high to ground on this LED. And if this one fires, then you will have a voltage across here. This one will fire, and anyway, they'll turn on so that you always have one op amp on, one op amp off, and the other ones, if it's on or off, those will turn off. So if these two were the same, then this one would not turn on. But if the voltage was high enough to turn this one on, then you'd have a high, low, low. And the high, low here turns this one on, but the low, low here turns this one off. And so you get an LED that actually moves position, which is super, super cool. So we'll come back to this. Let me show you the circuit first. All right, so here's the circuit, and I'm going to change the voltage with this little knob here. And you can see that the LED will change positions depending on the voltage, and if you needed it at a particular range, then you could use this to say, okay, I want it right there in the middle. That's my sweet spot. In fact, you could probably change that LED color to green. Maybe all these are yellows. Maybe make the outside ones red or something, right? You could play with this, but you can see it's the same circuit, but it's acting differently. It goes back and forth instead of just filling up a bar graph. I just think it's fascinating because I haven't seen this before, which is pretty nice. Okay, let's take a look at what we're doing here. Let's bring in a voltmeter, and let's turn that on so you can see it. All right, so how do we get that? So we're at 10 volts now, but how do we get that down to the middle here? Well, the middle one lights here at 6.7 volts. Let's see where it trips. It trips right around there. Let's see, I'll go real slow there. Right about 5 volts is there. And then as I go up, it trips to about 7.5. So right at about 5 volts, it goes down. And then right at about 7 volts, it goes up. So somewhere between 5 and 7 volts, that one LED in the middle will be lit. So anyway, you can adjust that resistor divider to give you any voltage range you want. On this particular thing, the resistors don't have to be equal values. You can set up whatever ratio you want. So now that we've seen the circuit and how cool it is, let's go ahead and look at the schematic again. Okay, so if you want to play along at home, I don't like 324, so I used a TLC 274. Okay, so you might be familiar with the TLO 74s and TL 274, but the TLC means it can operate on a single rail from rail to rail, from ground to some voltage. So I'm operating this from 0 to 12 volts right now. All right. And so that's the part I used. My input resistor, I used 10K. So 10K, 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 10K. And over here I just used 1K. Okay. So 1K, 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 1K. That's all there is to it. All right, just a fun little circuit. Yeah, I think it's pretty cool. All right, I know some people would like to see it, and some people maybe haven't seen it, so I'm going to wire this one up as well, so you can just see what that one looks like. All right, here we go. This is the bar graph here. As you go up, they light up in sequence, but they act as a bar graph.